So I just wanted to go over a couple of the problems from the class work. Um, we didn't get through all of it, so I'm just gonna go over those problems so you guys have them. So for practice problem number 4, we briefly talked about it in class. Um, so the question we're trying to answer here is: according to these models, is there a time t for t between 0 and 5 at which the total accumulated profit RT minus E of t is equal to 0? Justify your answer. So I talked about in class specifically about what function we're paying attention to. Um, so the function that we're looking at here is the total cumulative profit, which is the difference between RT and E of t. So I just what I said in class was just like say like that function is P of t. So P of t is um, so RT minus E of t. Let's just call it P of t just for profit. And what is the actual equation for this function? So you guys talked about how we have to RT, we have to choose this function because the interval is from 0 to 5, which falls within this interval 0 to 20. So RT needs to be 41, the square root of t over 20, and then minus E of t, and there's only one function for that. It's given in the problem here. So it's 3 log base 2 12t plus 4. So that's the function we want to use. And the question is asking us if, is there a time that this function, p of t, is equal to 0? So the one thing I noticed that people skipped in class was that people wanted to apply the intermediate value theorem, um, but most people just jump to like plugging in 0 and plugging in 5, which is part of the process. But if you're gonna try to say something about whether this function is equal to 0, you have to go through all the steps of the intermediate value theorem. And in the flow chart, if you guys look at the top, it says that step 1 is you need to verify that your function is continuous on the interval from 0 to 5. So if I'm looking at this function here, it's made up of a square root function and then a log function. So this function is defined for all the values between 0 and 5. So plug in 0, 2, 1, 2, 3, 4, 5. You're always going to get a number here, and then the same thing here. Okay, log functions is defined on this interval. So at the beginning of your work with the justification part, if you're going to implement the intermediate value theorem, you'll have to say P of t is continuous on the interval from 0 to 5. So I'm using the square brackets because it's a closed interval. So you need to start off with that. And then so that's condition 1 of the intermediate value theorem. The second condition is now you need to check the values. So most people did do this. So if you do P of 0, we need to figure out what that y value is, and then now we have to do P of 5 and figure out what that value is. So in the calculator, see, so if I plug in 0 minus 3 math, 2, 12 times 0 plus 4, you're going to get the answer of negative 6. So P of 0 is negative 6. And if I plug in 5, you're going to get 2.5. So we just did step 1 in the flow chart, and this is step 2. Okay, so now we can tie back to answering the question, is there a time? Is there for sure, can we say that the function will equal to 0? And so here we see that 0 is between 0 is between -6 and 2.5. Therefore, we can say the intermediate value theorem applies there. So we already said P of t is continuous, so now we've got to write our second part of our justification. Since P of t is continuous, on 0, 5, and P of 0 is less than or equal to 0, which is less than or equal to 5, the intermediate value theorem applies, and there is a time that P of t is equal to 0. Okay, so the big part I want you guys to get out of this is not only the procedure, especially the reading the question and paying attention to what's the function you have to deal with, but also how to set up your work and justify your answer.